Aquatic car is in
aquatic.
boat or submarine. That's a car.
I see, okay. Do you mean a car that can go in the water, basically?
On or under or both the water.
We've all heard of hydrogen being the next big thing in the propulsion business, but there still are issues around it. And some crazy folks have gone on to make engines that run on water.
Elon Musk, along with China and Dubai, is stepping into a revolutionary era of sustainable transport with the unveiling of water-powered cars. While Tesla has hinted at innovative designs, China's commitment to green energy and Dubai's rapid adoption of futuristic technologies could fast-track the development of these vehicles.
Dubai has unveiled the first prototype of the Hyperloop port. Now, this transport system from the future can travel at a lightning speed of up to 1,200 kilometers per hour.
Unlike traditional engines, these vehicles are designed to utilize water as fuel, an idea long discussed but never fully realized. Could water engines finally provide a sustainable answer to global transportation needs? Join us as we reveal the water engines that Elon Musk, China, and Dubai just released. Elon Musk, China, and Dubai, the future of water-powered cars. In a world that is increasingly focused on sustainability, clean energy, and the reduction of carbon emissions, a shift toward alternative energy sources for transportation has become a central theme in the global conversation. Among the many players driving this revolution are some of the most influential figures and regions, including Elon Musk, China, and Dubai. Recently, these three entities have made headlines by revealing their plans to develop water-powered cars, a move that promises to reshape the automotive industry and accelerate the world's transition to cleaner energy. Each has a unique approach to this groundbreaking technology, but together, they are ready to lead the way in a new era of sustainable transportation. Are there really going to be water engine-powered cars in the nearest future? Or is the future here already? Stay tuned to find out. Elon Musk, the renowned entrepreneur behind Tesla, SpaceX, and numerous other ventures, has long been a vocal advocate for sustainable energy. His work with Tesla has primarily centered on electric vehicles, which have been praised as a key solution to the world's dependence on fossil fuels. But Musk's broader vision for the future of energy goes far beyond EVs. Musk has always emphasized the need for a complete transformation in how humanity generates, stores, and consumes energy, particularly in transportation.
Tesla into universal filling station of EV era. Tesla will open part of its US charging network to electric vehicles, EVs, made by rivals now.
The introduction of water-powered cars represents an ambitious next step in this vision. Musk's announcement to develop water-powered vehicles is rooted in his commitment to reducing the global carbon footprint and addressing the environmental consequences of traditional fuel sources. The idea of using water as a fuel source for vehicles has long been discussed by scientists and engineers, but Musk's ability to combine cutting-edge technology and innovation brings this concept closer to reality. Water, a substance that is abundant and renewable, has the potential to replace fossil fuels, which have long been the primary source of energy for the global transportation sector. The science behind water-powered cars is based on the process of electrolysis, in which water molecules are split into hydrogen and oxygen atoms. Hydrogen, when separated from oxygen, can then be used as a fuel source. While the technology of using hydrogen for fuel has been explored for decades, the breakthrough that Musk's Tesla team is working on involves a new and more efficient method of electrolysis. For Musk, the water-powered car is more than just an environmentally sustainable solution. It is part of a larger strategy to challenge the geopolitical and economic implications of the world's reliance on fossil fuels. The volatility of oil prices and the environmental degradation caused by the extraction and burning of fossil fuels have made it increasingly clear that the world needs a more stable and clean energy source. Musk's vision for water-powered cars seeks to address these issues while providing a fuel that is universally accessible and abundant. But Elon and Tesla are not the only ones who have made plans to release a water engine-powered vehicle. China has also released statements on their progress concerning the same project. China is a country that has been praised for how fast and global their economy has become. Their technology development is not left behind also because they emerged as global leaders in renewable energy and electric vehicle development. They have also made significant strides in the development of water-powered cars. As the largest auto market in the world, China has been at the forefront of the push for cleaner, more sustainable energy sources.
China's appetite for energy is enormous. The country consumes about a quarter of the world's energy supply, 35% more than the US annually. Its energy needs have more than tripled since the year 2000.
The country has set ambitious targets for reducing carbon emissions and achieving carbon neutrality by 2060, and the introduction of water-powered vehicles is seen as a critical part of this strategy. China's interest in hydrogen as a fuel source has been growing for years, and the country has already invested heavily in the development of hydrogen-powered vehicles. But the shift toward water-powered cars takes this concept a step further. By combining hydrogen fuel cell technology with water electrolysis, China aims to create a more sustainable and efficient method of producing hydrogen, reducing the reliance on fossil fuels and creating a closed-loop system that significantly lowers environmental impact. In recent years, the Chinese government has placed a heavy emphasis on the development of green technologies, including renewable energy, electric vehicles, and hydrogen fuel cells. The nation has already established a strong foundation for the widespread adoption of electric cars, and now, with the announcement of plans to produce water-powered cars, China is setting its sights on becoming a global leader in hydrogen technology. Several major Chinese automakers, including BYD, Geely, and NIO, have already begun testing hydrogen-powered vehicles and are exploring the use of water as a fuel source. China's approach to water-powered cars focuses on creating a seamless integration of renewable energy sources like solar and wind power with water electrolysis systems. In this vision, electricity generated from renewable sources will be used to split water molecules into hydrogen and oxygen, providing a clean and sustainable supply of hydrogen fuel for vehicles. This model not only supports the global transition to clean energy, but also creates an energy ecosystem that is self-sustaining and resilient to the challenges posed by fossil fuel dependence. Dubai, on the other hand, has also made the decision to join in the race of companies and countries that are making plans to release water engine vehicles. Dubai is quite known for its extravagant lifestyle, iconic skyscrapers, and technological advancements. They have also announced plans to develop water-powered cars, joining Musk and China in the race to redefine the future of transportation. Dubai has long been a hub for innovation, attracting global attention for its ambitious projects and forward-thinking initiatives. The city's ruler, Sheikh Mohammed bin Rashid Al Maktoum, has made it clear that Dubai aims to be at the forefront of the global push for sustainability, and the introduction of water-powered cars is part of this vision. Dubai's decision to explore water-powered vehicles is driven by its commitment to creating a more sustainable, environmentally conscious city. The move represents a significant departure from the region's traditional reliance on fossil fuels and marks a bold step toward embracing renewable energy sources. Dubai is positioning itself as a leader in the development of clean technologies.
Dubai's Road and Transport Authority recently won the Middle East and North Africa Green Building Award in the category of the Green Building Project of the Year.
And water-powered cars are seen as a key component of the city's future. The UAE government has already committed to ambitious sustainability goals, including reducing carbon emissions and increasing the use of renewable energy. As part of this commitment, Dubai has been exploring various green technologies, from solar power to electric vehicles. The introduction of water-powered cars is a natural next step in the city's ongoing efforts to reduce its environmental impact and improve the quality of life for its residents. The water-powered car initiative in Dubai is still in its early stages, but the city has made significant progress in developing the necessary infrastructure to support this technology. But with every great plan comes challenges and setbacks. Keep watching to find out what are the problems that come with making water engine vehicles. Challenges and setbacks of making water engine vehicles. The development of water-powered vehicles has been heralded as a groundbreaking shift in the future of transportation, promising cleaner energy and a reduction in carbon emissions. But even with the bold announcements from Elon Musk, China, and Dubai regarding their plans to make water engine cars, the road to making this technology a reality is far from smooth. While the promise of water-powered vehicles is exciting, there are numerous challenges and setbacks that have hindered their progress. These challenges span across technical, economic, and infrastructural domains, presenting significant hurdles that have yet to be fully overcome. One of the primary technical challenges that has slowed the development of water engine vehicles is the process of electrolysis, which is central to the idea of using water as a fuel source. Electrolysis involves splitting water molecules into hydrogen and oxygen using electricity, a process that is energy-intensive and costly. Traditionally, the energy required to break down water into hydrogen has often exceeded the energy that can be extracted from the hydrogen, making it an inefficient process. While advancements have been made in improving the efficiency of electrolysis, these breakthroughs are still in the early stages, and the technology has yet to be perfected to a level that would make water-powered vehicles feasible for mass production. Even with improvements to the electrolysis process, storing and using hydrogen is still a major problem. Hydrogen gas, which is the fuel generated through electrolysis, is highly volatile and difficult to store efficiently. Traditional hydrogen storage methods, which involve compressing hydrogen into tanks, are expensive, bulky, and can pose safety risks. Hydrogen's low energy density also means that large storage tanks are needed to provide a significant driving range for vehicles, further complicating the logistics of producing and maintaining water-powered cars. Although some companies have made strides in developing lightweight and safe storage solutions, the technology is still evolving and has yet to be widely adopted in the automotive industry. Another major issue is the existing infrastructure for hydrogen refueling.
The Toyota Mirai is remarkably simple to fuel, thanks to improvements in both the hardware and process of hydrogen refueling.
Unlike traditional gasoline stations or electric vehicle charging stations, hydrogen refueling stations are scarce and not widely distributed, especially in regions outside of a few key markets such as California in the United States. To make water-powered vehicles a viable option for consumers, an extensive network of hydrogen refueling stations would need to be established. This infrastructure is costly to build and maintain, and it would require a lot of investment from both public and private sectors to make hydrogen refueling a practical option on a global scale. Without this network, water-powered cars would face the same limitations as electric vehicles did in their early days, especially range anxiety and a lack of refueling options, which would discourage consumers from adopting the new technology. The economic viability of water-powered vehicles is another significant challenge. While the promise of using water as a fuel source is appealing due to its abundance and renewability, the cost of developing water engine vehicles is high. The advanced materials and technologies required to build these vehicles, particularly the systems for electrolysis and hydrogen storage, are expensive. The manufacturing processes for water-powered vehicles are also not yet optimized, meaning that production costs are likely to remain high in the short term. This makes it difficult for companies like Tesla or automakers in China and Dubai to make water-powered vehicles affordable for the average consumer. Until economies of scale can be achieved and the technology becomes cheaper to produce, water-powered cars are likely to remain a niche market for wealthy early adopters. There is also the issue of public perception and consumer acceptance. Hydrogen as a fuel source has long been met with skepticism due to safety concerns. Hydrogen gas is highly flammable, and while safety measures are in place for its storage and use, the public is still wary of its risks. This skepticism extends to water-powered vehicles, which are still largely seen as a concept rather than a practical, everyday mode of transportation. Shifting public perception will require significant education and marketing efforts to demonstrate that hydrogen fuel cells and water-powered cars are safe, reliable, and efficient. The shift to water-powered vehicles faces significant geopolitical and economic challenges. Reducing reliance on fossil fuels would disrupt oil-producing nations, which rely heavily on petroleum sales, potentially sparking resistance from countries and industries invested in the current energy industry. This resistance could slow the adoption of water-powered cars and hinder the development of the necessary infrastructure. International trade and cooperation will also be helpful in overcoming logistical issues, as countries like China and Dubai work on developing water-powered vehicles. But differences in hydrogen production, storage, and refueling standards could complicate the global supply chain. Geopolitical tensions and varying regulatory environments may delay progress. The scale of the transition is another immense hurdle. The automotive industry is vast, with millions of gasoline and diesel-powered vehicles worldwide. Shifting to water-powered cars requires significant investment in innovation and infrastructure, which will take time. This transition is not a quick fix and will involve concerted efforts from governments, corporations, and consumers. Overcoming these technical, economic, and political barriers will be a long-term process, and while progress is being made, widespread adoption of water-powered vehicles will take years to fully realize. This opens up opportunities for hydrogen-powered vehicles to excel in areas where battery electric vehicles may struggle, such as long-haul trucking, heavy-duty transportation, and remote locations where charging infrastructure is sparse. And hydrogen can be produced from various sources, including renewable energy such as solar, wind, and hydropower, making it a truly sustainable fuel. When hydrogen is produced through electrolysis using renewable electricity, the process is entirely green, resulting in zero emissions from production to consumption. This positions hydrogen as a key player in the global transition to clean energy and a low-carbon economy. Building on the success of the Mirai, Toyota has continued to develop hydrogen technology, bringing it into new forms and applications. The Corolla Cross Hydrogen 2 being the latest evolution of this effort.
It is a hydrogen-powered car, not an FCEV like the Mirai, which is also here, but a hydrogen-powered car with an internal combustion engine.
Showing how hydrogen combustion engines could complement the fuel cell approach used in earlier models, and how far Toyota can go to shake the world with unimaginable technology and innovation. While hydrogen fuel cells are highly efficient at generating electricity, the combustion engine approach provides another pathway to clean transportation. By burning hydrogen directly, Toyota is able to use existing internal combustion engine technology in a more sustainable way. This could potentially lower the cost of transitioning to hydrogen-powered vehicles, as it builds on established manufacturing processes and infrastructure. The hydrogen combustion engine maintains many of the characteristics that drivers are familiar with, such as the sound, feel, and response of a traditional engine, but with significantly fewer emissions. For car enthusiasts who are hesitant to make the switch to electric vehicles due to the differences in driving experience, hydrogen combustion offers an exciting alternative that combines the best of both worlds. When it comes to the key distinction between Toyota's hydrogen and hybrid engines and regular gasoline-powered engines, we can't deny it. This lies in the fuel source and the combustion process. Conventional gasoline engines burn fossil fuels, releasing harmful emissions like carbon dioxide, nitrogen oxides, and particulate matter. Toyota, however, is advancing alternatives that produce significantly lower emissions while still offering high performance. A conventional engine relies on gasoline to produce energy through combustion. In contrast, Toyota has mastered the use of hydrogen, a clean and efficient fuel, as a key component of its powertrains. Hydrogen-powered engines maintain the fundamental characteristics of traditional engines while drastically reducing environmental impact. The transition from gasoline to hydrogen or electric power not only eliminates carbon dioxide emissions, but also offers a pathway to sustainable transportation without sacrificing driving enjoyment or engine performance. Toyota's hydrogen engine technology is built upon a sophisticated combination of modern engineering principles and fuel innovations. One of the most astonishing advancements Toyota has achieved is maintaining engine performance with hydrogen as the fuel source. This breakthrough allows drivers to experience the same level of power and responsiveness that they've come to expect from traditional engines, while eliminating the harmful emissions associated with gasoline. Central to Toyota's hydrogen engine design is the use of an advanced high-pressure hydrogen direct injection system. This system ensures that hydrogen is efficiently delivered to the engine's combustion chamber, where it is ignited to create energy. The high-pressure injection allows for precise control over the fuel flow, optimizing the combustion process and ensuring maximum power output while minimizing waste. This innovation ensures that Toyota's hydrogen engines can match the performance of gasoline-powered engines while offering cleaner and greener solutions. Hydrogen as a fuel is less energy-dense than gasoline. It contains less energy per volume. To address this challenge, Toyota has equipped its hydrogen engines with turbochargers, a critical component that allows the engine to compress air and increase its energy efficiency. The turbocharger helps ensure that the engine can generate sufficient power, compensating for hydrogen's lower density. By compressing the air intake and increasing the amount of oxygen in the combustion chamber, the turbocharger enables the hydrogen engine to deliver performance comparable to traditional engines without compromising on acceleration or power. The use of turbochargers is essential for maintaining the balance between high power output and low emissions. Toyota's engineers have skillfully integrated this technology into their hydrogen powertrains, ensuring that drivers can enjoy dynamic and responsive driving experiences while knowing they are reducing their carbon footprint. Hydrogen-powered engines offer a unique combination of efficiency and low emissions, positioning them as a promising solution for the future of eco-friendly transportation. Unlike gasoline, which produces large amounts of carbon dioxide and other harmful byproducts during combustion, hydrogen burns cleanly. The only byproduct of hydrogen combustion is water vapor, making it an environmentally friendly alternative that can significantly reduce the impact of transportation on the environment. Beyond low emissions, hydrogen engines also have the potential for superior efficiency. Toyota's focus on optimizing hydrogen combustion ensures that its engines are not only clean, but also capable of extracting the maximum amount of energy from each unit of hydrogen. This efficiency is critical in reducing fuel consumption and making hydrogen-powered vehicles more practical for everyday use. While hydrogen engines represent a major part of Toyota's eco-friendly strategy, the company is also a pioneer in the development of battery electric vehicles and hybrid technologies. Toyota's belief in hydrogen is evident, but the company is equally committed to electric solutions, recognizing that a multifaceted approach is essential for achieving global sustainability goals. Toyota's electric vehicle lineup, which includes both hybrid electric vehicles and plug-in hybrid electric vehicles, showcases the company's versatility in combining various forms of clean energy. The hybrid systems combine a gasoline engine with an electric motor, enabling the vehicle to run on electricity at low speeds and gasoline at higher speeds. This approach reduces fuel consumption and emissions while maintaining convenience for drivers. Plug-in hybrids, on the other hand, allow drivers to recharge their vehicles using external power sources, extending their electric driving range and further reducing the need for gasoline.
In pretty much all other respects, the plug-in hybrid CHR is very similar to the regular hybrid CHR.
The key difference between HEVs and PHEVs lies in their battery capacity and charging capabilities. HEVs rely on a small battery that is charged by the engine and regenerative braking, allowing the vehicle to switch between gasoline and electric power seamlessly. PHEVs, however, feature larger batteries that can be charged using an external power source, providing a greater electric-only driving range before the gasoline engine kicks in. Toyota's leadership in hybrid technology has helped the company cement its reputation as a green innovator, with models like the Toyota Prius setting the standard for eco-friendly driving. The secret to the clean operation of hydrogen engines lies in the combustion process. When hydrogen is burned, it combines with oxygen to produce energy, and the only byproduct is water vapor. This process eliminates the harmful pollutants that are commonly associated with gasoline combustion, such as carbon dioxide, sulfur oxides, and particulate matter. Toyota's hydrogen engines represent a transformative step towards a future where vehicles contribute minimally to air pollution and global warming. Toyota's success with HEVs and PHEVs has paved the way for the company's exploration of even greener technologies, such as hydrogen-powered cars and water engines. Toyota's hydrogen-powered engines aren't just limited to consumer vehicles. The company has also ventured into motorsports with its hydrogen combustion engines, demonstrating that eco-friendly vehicles can deliver high performance on the track. In racing environments, hydrogen engines have shown that they can match the power and speed of traditional gasoline-powered race cars while drastically reducing emissions. The use of hydrogen engines in racing shows Toyota's commitment to developing solutions that maintain driving excitement while addressing environmental challenges.
We'll see just how quick it is later on in the video because I will be launching this car, of course.
It proves that clean energy vehicles are not limited to slow or sluggish performance and can compete with the best in the industry. With Toyota's massive innovation, the gap between traditional gasoline cars and eco-friendly alternatives is closing. Toyota is creating a new generation of vehicles that promise a cleaner, greener future for transportation. The chemical structure of a water engine, which is also the hydrogen fuel cell engine, is based on the reaction of hydrogen and oxygen to produce electricity and water. This innovative technology has the potential to revolutionize the way we power our vehicles and devices, offering a zero-emission alternative to traditional fossil fuels. But we cannot ignore the threat it tends to create. Yes, the hydrogen-powered innovation and water engines are massive, and we are all excited how Toyota is bringing it to us. But don't forget though, no matter how good it is, there's always a bad side. What are these looming fears concerning this innovation? You really want to know about it. New hope brings new challenges. The concept of green transportation is grounded in sustainability, yet achieving true sustainability requires more than just reducing emissions. Manufacturing eco-friendly vehicles, be it electric vehicles, hydrogen-powered cars, or even water engines, comes with significant resource and energy demands that raise questions about the environmental impact of production. In electric vehicles, the electric control unit is responsible for managing various electronic systems, from battery management to power distribution and motor control. Hydrogen-powered vehicles also rely on advanced electric control unit systems to manage the hydrogen fuel cell and combustion processes. These systems are intricate and require significant development to ensure they function reliably in all driving conditions. The complexity of electric control unit management can make these vehicles more difficult and expensive to produce and repair, potentially limiting their marketability. While hydrogen fuel cells are a promising technology, their current production is expensive. The fuel cells themselves contain costly materials such as platinum, which is used as a catalyst to facilitate the reaction between hydrogen and oxygen. As hydrogen-powered vehicles become more prevalent, efforts to reduce the reliance on precious metals are essential, but they also add complexity to the research and development process. The complexity of green vehicle technologies is compounded by global supply chain challenges. As automakers rush to meet growing demand for eco-friendly cars, supply chain bottlenecks could slow production and limit availability. The complexity of producing green vehicles drives up costs, making them more expensive than their gasoline counterparts. Although government subsidies and tax incentives have helped reduce the price of electric vehicles, the average cost remains higher than that of a traditional gasoline-powered car. The same is true for hydrogen-powered vehicles, which are priced at a premium due to the high cost of fuel cell production and hydrogen infrastructure, not to mention a vehicle powered by a water engine. Hydrogen stations are relatively scarce, even in countries that have invested heavily in green technologies, such as Japan and Germany. The cost of building a hydrogen refueling station is high, and the distribution of hydrogen fuel is more complex than that of gasoline or electricity. This infrastructure gap could limit the adoption of hydrogen-powered vehicles, especially outside major metropolitan areas. Toyota's water engine could pose significant threats to various industries and aspects of society. The rapid technological advancements sparked by a water engine could make existing technologies obsolete, potentially leading to patent and intellectual property disputes. The high development and production costs of mass-producing water engines will definitely limit accessibility, while public acceptance and education may be challenging due to the newness of the technology. Hydrogen fuel cells are less durable than traditional internal combustion engines or electric vehicle batteries, especially under extreme driving conditions. The harsh environment inside a fuel cell where high temperatures and corrosive chemical reactions take place can degrade the materials over time, reducing the fuel cell's efficiency and lifespan. Although advances in material science are improving fuel cell durability, Further research and development are needed to ensure that hydrogen vehicles are as reliable as gasoline or electric vehicles over the long term. Hydrogen fuel cells face performance challenges in cold weather. At low temperatures, the water produced by the fuel cell can freeze, preventing the vehicle from starting or reducing its efficiency. Engineers are working on improving fuel cell performance in cold climates. But for now, this remains a concern for consumers in regions with harsh winters. Storing hydrogen gas for use in vehicles is not without its challenges. Hydrogen is the smallest and lightest molecule, making it prone to leakage from storage tanks if not properly sealed. Hydrogen must be stored under extremely high pressure to achieve the energy density needed for vehicle applications. While modern hydrogen storage tanks are designed to be robust and safe, the public perception of hydrogen as a potentially dangerous fuel due to its association with the infamous Hindenburg disaster remains a psychological barrier for many consumers. In regions where hydrogen refueling stations exist, the price of hydrogen fuel is typically higher than that of gasoline or electricity. This is due in part to the costs of producing, transporting, and storing hydrogen, which are passed on to consumers. But in all, Toyota has emerged as a leader in eco-friendly transportation, leveraging both hydrogen, electric technologies, and a promising greener future, the water engine. By maintaining engine performance while shifting to greener alternatives, Toyota's innovative approaches have set it apart from traditional internal combustion engines, establishing the company as a front-runner in sustainable mobility. The water engine promises to be an even more remarkable achievement. By leveraging the power of hydrogen extracted from water, Toyota aims to create an engine that is not only zero emission, but also virtually limitless in its potential. Imagine a world where vehicles can be powered by the most abundant resource on the planet, water, without producing a single gram of emissions. This is the vision that Toyota is bringing to life. What are your thoughts on Toyota's technology breakthrough? Drop it in the comments section below. If you enjoyed watching this video, make sure to like, share, and subscribe to our channel for more. Also, click the next video shown on your screen. You will enjoy it.